How you doing?
Good.
You guys a little sleepy?
No.
My name is David Gregg. I work at the Iron Yard still. I'm one of the last 5 employees at the Iron Yard globally at the moment, down from a couple dozen campuses. So I work on their corporate training team. I'm an associate instructor. Right now we're working with Liberty Mutual, finishing off our contract that we have with them. So for the last 9 months I've been with them since I was a graduate with the Indy campus here in Ruby on Rails. But since then I've been teaching JavaScript mostly with Angular, React, Sales, and related technologies, and a little more recently Java, Spring Framework, Spark, and stuff like that. So it's been interesting spending my first year in my transition from IT into software development and teaching code rather than actually doing it on a daily basis. But actually, let me say it this way. I do a lot of programming languages. I don't get a lot of chances to actually exercise the frameworks as much, although I know how to explain how they're connected to each other. So that's been kind of an interesting experience. But I've got a long history with regular expressions that goes back to my childhood. My first computer was a Tandy with DOS 2.0 on it, 2.1 what it was. And so I started with shell scripting, or command shell scripting. Got into JavaScript in high school, a little bit of Visual C++ and Visual Basic. A few years down the road, got into PHP. Most of my time with JavaScript was all in the ES3 era. Didn't get really into the newer stuff, the ES 2015 stuff until the last couple of years, and that's been really exciting to see the massive changes. It kind of felt like night and day to me when I came back to JavaScript. So that was, I mean, I've just been really super excited. So I've been so excited I've been reading specs. The regular expressions, I think, started out with me just trying to make sense of my MP3 folder. All the file names in there, different standards. You know, is the band name first? Is the album name first? Is the song name first? What do you put in there? So I learned regular expressions just to kind of automate standardizing my music library, like probably 2001, maybe 98, not really sure. Then I started using regular expressions in JavaScript and PHP, and I found myself using it in Microsoft Word and in Notepad++, and you could tell I was on Windows in those days. Then, about 2009, 2010 or so, I was employed by Author Solutions, which was at the time the largest publishing, independent publishing company in the world. So if you had money to blow or a mortgage to blow, then you could come to us and we'd publish your book for you, and we didn't really care about the quality. So New York Times journalist came to us, came to our corporate marketing department one day and said, I've got this hunch that since the age of the internet, there's been an increase dramatically in the number of young authors. But none of the traditional publishing companies would have any numbers on that because they refuse to publish young untested authors. So the only people who would make sense in the industry to know this would be you, Author Solutions. But we had lost our birth date field over the course of 3 data migrations over 3 years. So we were at a little bit of a loss as to how to get that information back. At the time, I was working as really a generalist. So what I called myself back then was a special project specialist. So they just threw me at whatever problem they had. I didn't have the developer label, so I didn't have like developer tools set up on my machine. I didn't have admin access, but what I did have was the ability to double-click on a batch file, use RegEx and Notepad++, and write modules in Excel in VBA. And so I exported a whole bunch of reports from the author biographical data from Salesforce and cleaned up all those comma delimited files in Notepad++ using RegEx, and then opened them in Excel and used this VBA module with an 8.5 by 11 worth size regular expression to go through all that author biographical data and make best guesses as to whether or not this person was young. Rule out everyone with the word veteran in the author bio. Include people who use the word or the phrase high school. Date ranges and all kinds of things. It was kind of a massive endeavor, but the company was like, hey man, New York Times article, so let's push for it. Was able to get significant enough sample data that we were able to give them some percentage figures of increased growth in young author books over the course of 10 or 12 years, which was nice. But that experience really drove home for me the power of regular expressions. It also drove home for me the power of actually having tools that fit your job, which at the time I didn't have, which is why I was using regular expressions, at least in Excel and VBA and using Notepad++. But it got the job done, and that's what matters. So in just about every position I've had, whether it was IT or whether it was in some generic technology-oriented product creation job, I've been able to use regular expressions. So let me ask you a question before we get into this. How many of you feel a little intimidated by regular expressions? Right? I've been there. I remember those days. I'm here to tell you that they're not really that scary. They're more unreadable than they are complex. There's really, for the most part, a few core rules. And then the rest of the stuff is just you grow into it. And 90% of the time you're not going to be writing long regular expressions when you are going to be writing regular expressions. So we're going to talk a little bit about what you use it for, why you would use it, when you wouldn't use it, some best practices, some Ruby methods, a little bit of JavaScript differences when it comes to how JavaScript interprets regex and expects you to write regex. So a regular expression is a syntax for describing patterns in text. It's really just as simple as that. There's a guy named Clean in 1951 who wrote a paper on how you interpret or how you parse what he called, or what they were calling in those days, regular language. This is still a term. It's really, don't bother looking it up unless you're a mathematician or a computer science major. It's annoying to try to make sense of what they mean by regular language, but the best way that I can boil it down from what I've picked up is that a regular language is a language that you can interpret using essentially just a switch case statement with no recursion. Does that make sense? Just basically a bunch of ors. This or this or this. Just a massive if-then-else statement. Right? That was a regular language. Now these days, and regular expressions were designed to be able to parse those. Now, if you've begun thinking ahead a little bit, you'll recognize that matching pairs like an opening and closing parenthesis requires coercion when you've got them nested and stuff in order to make sense of them properly. Otherwise, you might grab the first parentheses and grab the next closing parenthesis and think that they were matched. So you've got to have recursion in there. So regular expressions didn't work in those days on anything nested, context-free grammars and so forth. But these days, regular expression engines aren't just for regular expressions per se, so far as the proper mathematical term. They give us a lot more power than that, especially in Ruby and Perl and other implementations that really add extensions to the regular expressions engine that they use. In Ruby's case, it's Onigma,
at the moment is the regular expression engine that we use. It used to be Onimagura. Oh, sorry. How do you pronounce it? Somebody remember? Onigurumo? Onigurumo, that's what it is. Another big popular one, I think it's the one that Java uses, that PHP uses, is PCRE, which means the Perl compatible regular expression engine, which is funny because Perl doesn't use it, and there are some minor differences. Perl really leads the way when it comes to additions to regular expressions engines. Enigma, which is again what Ruby uses, tries to follow that pretty closely. So it's pretty close to what most developers can consider the standard, although there is no official global or international standard for regular expressions. Regular expressions are often used to select substrings that you've described in the form of these patterns, or validate whole strings, or perform search and replace operations. RegEx is neither trivially readable. So you see there, that is directly from Devise's source code I pulled out of there this afternoon. That's a very rudimentary email pattern. It's really easy to trick that one. A little later I'll get into why you shouldn't worry too much about trying to validate things like that. But while RegEx is is not trivially readable, it's also not trivially replaceable. In many cases, you would need complex functions that are looping through strings, finding substrings by their indexes, storing those indexes, doing math between the indexes, making many function calls. Has anyone in here actually tried to write something that you really should have used RegEx for in just standard like substring searches and things like that? Have you ever tried to do that? It gets really complicated really quickly and really time consuming, and you're writing a lot of code. So, back one. I could do this. This is a Ruby function for validating a social security number. So right at the top, I've got a guard clause, just make sure that we've got the right number of characters in the string. Then I split it up by the dashes, and then I've got another sort of guard clause before we get down into all of the looping that checks to make sure that the three different parts of the social security number are the right length. And then down here I define an ASCII code range, and those, if you look those up, that's the range of the digits in the first 127 characters of ASCII. And then we loop through those three parts. And for each one, we get the characters for that string. And then we check to see whether or not the character code for that character is in fact in that range. You might think that you could coerce it to integer, but if you pass a string that has like 0xFF to the integer constructor, it's just going to turn it into 255. So this is the safest way to do that if you're not using regular expressions. But you could do this. That's a regular expression with the 3 equals operator. And this is just the simplest way to write this. There are maybe better ways of writing this regular expression. But what I'm saying is I want 3 digits followed by a dash, followed by 2 digits, followed by a dash, followed by 4 digits. And that's what I'm expecting the string to match with. And that's going to return true or false. So I don't think this is too terribly unreadable, especially with resources like Rube Euler. Rube Euler here is a Ruby regular expression editor. So you can type in your regular expression. It will show you underneath or you put in your test strings down here, and it will show you your matches. The match results right here. We're matching those 2 date strings. You can see your matching groups. You can change your Ruby version if that matters to you, but at the bottom, you have a RegEx quick reference cheat sheet. And down right here, you see that /d means any digit. And we'll get back to that in a minute and what all these things mean. And by the way, there's this nifty little link to the Pickaxe book. Now, that's an older version of the Pickaxe book, but much of that stuff in there is still accurate for Ruby and regular expressions in Ruby. But a tool like this goes a long way to helping us feel confident that our RegEx is doing what it's supposed to be doing. You put your test strings in there, you try out your regular expressions, and you see what it comes back with. Now, I'm going to be using this one. This is Regular Expressions 101. I've zoomed in a little bit. The whole site normally looks like this. And you can type your regular expressions in here. Let me grab this regex string from Rube Euler and put it right there. All right. Now, pattern error. Oh, that's right. I'm in JavaScript. There we go. All right, there you go. PCRE is closer to what Ruby uses than the JavaScript engine. So you see here that our tool is giving us color-coded help. I can see my names capture group. I can see that this /d matches a digit. I can see my quantifier, and so forth. And I can see down here what I've matched. Just this one part. Really useful. Also, over here, now, when you're zoomed out, you'll see it on the right-hand side. For me, I've got to expand this. And you've got all of your cheat sheet stuff, which is really nice. You can also see the explanation written out in words of each part of your regex and what you've matched. And you can see your matching information. And then over here on the left, you can set what flavor of regex you're using. They don't unfortunately have Enigma in here, but PCRE, as I've said, is pretty close. And then you've got the regex library, which is just a bunch of people's regexes that you can search through. Super useful. So this is the main tool that we recommend to our students with the Iron Yard corporate training. Put things in here. You can also write unit tests, which is super nice. You can do search and replaces and see what the substitution results would be like. You can change your flags and so forth. So really great. There's also another one called regexer, where it's just an R after the X. That one's good, but I find that this one's kind of the best out there so far as features. So let's go back here. I recognize that song. So where can I use regex? You can use regex in some markup programming languages that you're likely to work with. It is everywhere. You can use it in Java, you can use it in JavaScript, you can use it in Ruby, you can use it in PHP, you can use it in Perl, you can use it in C++, you can use it in C, you can use it everywhere you're going to go. You can use it in many of your databases, Postgres, MySQL, Oracle, Mongo, Microsoft SQL. You can use it in many commands in every major shell, whether that's on Windows, whether that's on Mac OS, or whether that's on Linux, whatever your flavor is. You can use it in every decent code editor. So I've got a whole bunch of lines in this file, this massive HTML file that I've got to sift through and pull out some part that kind of maybe varies a little bit from line to line. Can't just do a normal copy that line, put it up there, and do search and replace and put nothing in the replace field. I've got to actually write a regex, and if I do that, it can save me a lot of time if I'm familiar enough with regex to just kind of get up and go, or if I can use the tools in order to test things out and see what my results would be. And you can use regex in many general-purpose text editors, like TextEdit. Microsoft Word has a little neutered version of regex in it. Google Docs even now, since the last couple of years, they've added regex support. So you can use regex sort of all over the place. So it kind of behooves you to get on board with it at least a little bit, at least enough to where you can be confident that if you need to scale at some point to something a little more serious with RegEx, you can get moving on that. So what we're going to do is we're going to walk through the basic concepts. This is sort of like some of you who already know quite a bit about RegEx will know some of the things that I'm not talking about yet. Deliberately, I'm going to postpone some of those subjects, like some of the shorthand things, because this little path I'm going to take you through, in my experience, is just about the clearest way to begin you on the path of learning RegEx, and a little towards, a little into it, those of you who are a little more experienced maybe get a few things out of it, especially when we look at the Ruby methods and patterns that we'll be able to exercise. So we're going to talk about atoms, we're going to talk about character classes, we're going to talk about groups, quantifiers, anchors, and flags. So those are what I would consider sort of like the most elemental parts of regular expressions. So atoms, an atom is a character, a grouped pattern, or position. A character class matches a single character from a given set of characters. So here I have a character class. Those are those brackets right there. And what this means is I'm going to match one character that's either an A, a B, a C, a D, a 1, a 2, a 3, or a 4. The next line says I'm going to match any one character that is not an A, a B, a C, a D, a 1, a 2, a 3, or a 4. And the next line after that has two ranges in it. I'm going to match anything that is lowercase z through, or lowercase a through lowercase z, or lowercase 1 through 4. That doesn't make any sense. Forget the lowercase part of it. And then there are some shorthand variations of those, but that is the only, with maybe one exception, character class concept that you actually have to learn in RegEx. That will cover all of your bases for you. Those are the building blocks right there. Character classes. They match one character. Groups, they group. They group real good. There's a few kinds of capturing groups. The one we use the most is called the one we use the most is the capturing group. It's going to remember what you've matched with that pattern. In this case, we're matching this string ki and then either a d or a t, and we're remembering that. And depending upon the method that you've used this in, or the context you've used it in, you can get access to that through usually an indexed-like variable, usually like a $1, or if you're in like sub or g sub in the replace string, it would be like a \1 because that's the first capture. Then you have non-capturing groups. They don't remember things. Non-capturing groups, it's threatening to, it's tempting to forget that these are here or to kind of overwrite them, but they'll save you some performance, especially if you're doing a lot of looping through large strings or large collections of strings. Non-capturing strings, if you don't have to recall that data later, use that for grouping things together. And then alternation is just basically a logical OR that you can, in this case I'm using it inside of a capture group because that's where you'll see it most often. But if your regular expression has no capture groups or anything, you can still have one of these alternation operators in the middle there. And what that is saying, that the effect of that is identical to the effect of the first example. It's going to be giving either kid or kit. And then finally, there are named capturing groups. These can be used to recall matches by name. So instead of using $1 or \1 to get access to the first capture, I can actually now use the variable or reference kit or kid to get access to whatever the match was, which is really nice. And we'll see that come come to play a little later when we look at Ruby patterns. Then we have quantifiers. Quantifiers match the previous atom, x to y times. So the first example there, we're saying I want to match an A 3 times. So that's equivalent to saying I want to match AAA. The next example, remember that is a character class. We're only matching one character, but that character could be either an A, a B, or a C, and I'm going to match it between 1 and 3 times. The next one is going to match an A 0 or 1 times. And then the last one's going to match A, B, or C 2 or more times. It's open-ended. And there are shorthand variations of those as well, which we'll get into. Anchors refer to a position, a canonical position. In Ruby, with a caveat that caret refers to the beginning of the line, and the $ refers to the end of the line. In Ruby, if you use the multi-line flag, we'll talk about flags next, then that actually refers to the beginning and the ending of the string. No, sorry, not Ruby with the multi-line flag. Multi-line flag in Ruby does something else. The multi-line flag in JavaScript is what does that. Because a lot of us are jumping back and forth between Ruby and JavaScript a lot. So the M flag in JavaScript does that. Then you've got the A and the Z, the capital A and the lowercase z match the beginning and the ending of the string. Remind me a little later and I'll talk about the difference between lowercase z and capital Z. But that's probably the one that you want to use most often, even though you'll see the caret and the $ more frequently, because usually you want to deal with a string rather than lines. If you're dealing with something that's got a lot of lines in it and you deliberately want to deal with lines, then sure, use the first example. But you can get yourself into maybe some surprising situations by capturing a lot of new line characters in your, or failing to go past the new line characters if you're relying upon those anchors to mean something that they don't. And then the final examples for anchors, we have the lowercase b and the capital B. They match respectively word boundaries and non-word boundaries. Remember, that's the position. So a boundary would be something like this, like a standard English word up to a space, but not including the space. Or up to, I think even a dash, a paren, a new line, a period character, a comma. The word boundary would start where that character starts, just before that final character. That's not a part of a standard English word. So before I move on to flags, I'm going to go back here and we're going to look at the way these behave a little bit in RegEx 101. So we've got the character classes. So I want to match A. I've got my 3 A's. That doesn't match anything because I don't have 2 A's. But I can match A, B, C, D, E, F, G. Which is cool. I don't want to match A, B, C, D, E, F, G. I get all the other characters that aren't one of those. Or, what was my other example? There we go, the ranges. I want to match A through G, or anything that's not A through G, or anything that is. It's not so bad. Can you guys see that back there? In the back? Yeah. Capturing groups. I want to match anything that's A through G, and I want to remember it. And then maybe I'll use a substitution in order to double check that I've in fact remembered those things. So let's say I want to replace, or I want to say $1, which is my capturing group. And you'll notice that the result is the same because I've put what I remembered right back where it should belong. If I do this, I'm just putting $ where those characters are. Maybe I want to say, I want to wrap what I remembered in boat. Or maybe I want to wrap it in a tag of some kind. And I've wrapped every single one of those characters that match in that string. Super nice. Great in your editor. All right. Oh. And then non-capturing groups. Let's have an example of a non-capturing group here. I'm going to match anything that's not A through G in a non-capturing group. Oh, because I didn't have it in brackets. Yeah. So now if I look at my substitution, without the capturing the question mark colon, I'd be able to do a $2 to get access to that. But that doesn't work. See how it's red? Not pull anything back. All right. And then finally alternation. I can say I want to match A or B. Oh, there is no B in there. D. Cool. Then basic named capturing groups. So this guy, I want to say and I don't think I can use that named capturing group down here, or can I? That I've not actually tested. No. But if I were in certain contexts, which I'll show you later, I'd be able to access what I've captured there using that variable. Okay, then quantifiers. I want to match A 3 times. I don't have any of those. So why don't well, I've already shown you D, so I don't mind doing that. A succession of 3 numbers. It's the same as doing this. Well, if I want to match 1 to 2, it's going to grab me this little guy and that little guy, and both of those. I could match 1 or more. I could match 2 or 3. I can match 0 or 1. Now, this one is one you have to be careful about a little bit. If you use this a little too willingly, you see that we're matching positions. See all the little purple dotted lines there? Don't overuse that too much if you can help it, because it's kind of a burden on the engine. Regular expressions are optimized. I mean, they've had, what is it, like 70 years to optimize some of these things, but you know, you can save yourself some performance if you can find other ways of saying that. All right. And then anchors. Anchors are great because it means I can select. Now in this case, I do want the lines because I do have multiple lines. I want to be sure that everything from the beginning of the line to the end of the line is a certain thing. Doesn't matter what I put in there right now, unless I have something identical to one of those lines, or a pattern that matches the whole line, I'm not going to match anything there. So I'd actually have to put in something like, let me escape some parentheses, and put 3 digits in there, space, 3 digits, dash, 4 digits. That's the way it would render in Ruby. Does that make sense? We've got our anchors there, and we're saying this is a complete line. That's all we expect. Or I can say I only really care about lines that begin this way. Or lines that begin this way. Or there's my period, lines that end that way. Cool. And the word boundaries. See where the word boundaries are? It's marking those positions. So from a word boundary, I want any word boundary whose next character is a D. Non-word boundaries. And so now I'm matching the positions in the middle of the words. Very useful things. Now we'll move on finally to flags. Now I still have the habit of calling them flags because I really have spent more time in the JavaScript world. Ruby calls them options. Vim calls them modes. So those terms are kind of interchangeable, but the gist of it is that a flag, an option, a mode changes the way that the RegEx engine behaves, what it expects. So the most common one that you'll see and no doubt have is the I, which means ignore the case of this regular expression. I want to be case insensitive, which is great, because then in my character classes, I don't necessarily have to say A-Z, capital A dash capital Z in order to match all of my standard English letters, whether they're capitalized or not. This is another one. This one you won't find in JavaScript, but is in Ruby, and that's this X flag. It ignores white space. Super awesome. Now you can put some space in the middle of your relatively complicated regular expressions. And I'm using this opportunity to also introduce the comments grouping. Everything inside of that is ignored. I can write something that explains what my previous pattern was. But that's the X. And then just a comment, in JavaScript and ECMAScript, you can get multiple matches with the G flag, the global flag, which I bring up because many of you will be familiar with it. Ruby doesn't have that. In Ruby, we do global searches. In other words, we return multiple matches by just using different methods, like gsub instead of sub, or scan. Now we'll get into the shorthands. Any questions so far? All right. So the only character class shorthand that arguably you need to know is the dot. The dot means any character. And the only reason why I say that it's the only really mandatory shorthand character class is because there's really no way to say any character other than the dot. Now by default, it means any other character than the new line, which in RegEx is /n. But in Ruby, and I'm getting it correct this time, the multi-line option, the M, toggles this so that the dot will match new line characters if you need it to. Then there's the /W that matches word characters. Word characters are alphanumerics, A through Z, 0 through 9, and underscores. So those are your word characters. The capital D negates that. It means the opposite of those things. I want anything that's not alphanumeric or an underscore. There's a pattern there in RegEx. This isn't universal, but most of the time you see a capital letter, it's the negation of the lowercase version. Lowercase d means digits. Uppercase D means non-digits. Lowercase s means white space. Capital S means non-white space. So let's look at this. I want to match some digits and some white space. I want to match anything other than white space. I want to match word characters. I want to match any kind of special character other than underscore, but using the capital W. I want to match any special character followed by 2 digits. And there we go. Maybe I want to match anything like that, which is that a good example? Let's see. Let's invert this. Anything after a non-word character, which is a digit or a normal word character. There we go. All right, then finally, our friends, the new line character and the character return. Character return, obviously, if you're not using Windows a lot, you're not going to have to use that one a lot. But if you're in a Windows environment or working with Windows files and in your text editor and you're trying to match around a new line, you're going to have to expect that /R. Because Windows files end with both a new line and a character return character. All right, then we have our quantifier shorthands. This is wrapping around to the characters you guys are most likely accustomed to if you've used RegEx in the past. The first one gets a big disclaimer, avoid that one. There lies hellfire. That guy is greedy. There's a lot of processing power behind that one. We're saying this thing is both optional and could be the size of the world. 0 to ad infinitum. That's what that guy means. You typically don't need to use it. The rule of thumb is don't use the asterisk in RegEx unless you know you need it. Or if you're in Microsoft Word, because it means something different in Word's version of RegEx. The main one that you're going to refer to time and time again is the plus sign. Plus sign is equivalent to 1 or more. You can obviously see where that's useful. I want to match 1 or more A's. I can just say A+. Then the question mark is equivalent to between 0 and 1. Colloquially, it means optional. And it sometimes means lazy when we combine it with the plus symbol, and you get the useful lazy quantifier. So let's see how these behave in our editor. So I want to match a word character 1 or more times. That's nice. Now I don't have so many matches. Matching the same things, but in fewer groups. 1 or more characters. Oh man, let's see here. Let's match digits 1 or more times. Up to a new line maybe, or up to the end of the line. How about this? Let's put in something a little more complicated. What should we do? Food. I'm mixing my Ruby and my JavaScript, I know. I want nested parens ultimately is what I want. Some stuff. Alright, so now what I want to do is I want to match things. I'm going to turn off this multi-line flag here. I want to look for paren. No, I really should have this all in one line. Let's just pretend that's a method. Okay. Let's just pretend that food is a method there. So what I'm doing is I'm saying that I want to match an opening paren and a closing paren with 1 or more of any character in between. But what I'm getting in this case, now in the real world, this would not, so this isn't a very good example for you, but what it's doing is it's being greedy. That's one of the most basic principles of regular expressions. It's greedy. It's going to try to grab as much. It's a cookie monster. It wants to eat all your cookies. So it's grabbing as many of those cookies, as many of those characters across its available line as it can. So it's starting here, and it's going to pass over this one, which may be by design, and in this case, likely it would be. But what if I wanted to stop at this per end? That's where I want it to be lazy, and the way you do that is you add that question mark. Ooh. Okay, hit the right key. There you go. Do that. With or without. That's one of the most useful combinations there. Matches between one unlimited times as few times as possible. Really great. All right. So now let's just cover a few basic regex patterns. I'm not going to be very verbose here. I've not worked in Ruby on a daily basis for 9 months. But there's some really cool things in Ruby when it comes to regular expressions, and you can really start to feel when you start looking into what sort of regex methods there are, what string methods that implement regex, what enumerable methods implement regex, and what just basic syntactic features implement regex. You really start to feel how much Matt's enjoyed what Perl had to offer in some ways when designing Ruby. So you look at this first one, this is what we call the match operator. It's going to have a closing paren there that's not got a brother. The match operator is going to return the index of the match. Obviously this is, otherwise it's going to return nil. So you're still going to get a truth or falsy value out of there. If you want to put that in a statement, that works. So I'm matching, in this case, I'm matching 4 subsequent digits right up at the end of the line with that $sign. The next one, I'm doing a named capturing group for the same string. This time, the named capturing group actually means something. Now, this is one of the things that's likely going to surprise some of you, even some of you veterans in the world of regex. That name birth year is now an available variable in this scope. So let's look at that. It's not letting me increase the font size. Can you guys see that?
No.
I can't. Commitment. It's letting me. There we go. All right. You know what? Do it this way. Okay. What was it we had? Or this guy, right? No, it wasn't the one. I used my console copy key in the browser. There it is. So now we've used the match operator. It's giving us the index where that birth year match begins, which is right at the beginning of this one. And now if I type birth year, you guys ever seen that before? Isn't that weird? I don't know whether I like it or not. But it's a thing. Then you have the subsumption operator, affectionately known as the 3 equals, which returns a Boolean. That one's rather straightforward. I don't think I even need to show that. You guys, you newer Ruby guys, you know what the subsumption operator means? It means it's matching classes, but it's also doing, now this is depending upon the class that it's implemented on, this operator, but it means that this thing can fit inside this thing. This thing subsumes that. In this case, Ruby is saying that this string can fit inside this pattern. But you could also have the class string over here, and you would still return true because this thing is subsumed by the concept of string, by the class string. Then we've got a few others. We've got the bracket accessor. You ever see this? Instead of passing in a number to get an index, an indexed character in that string, you can actually pass in the regex to match just that 1983 just right here. I actually kind of like that one. Isn't that cool? I don't have to call a method to do that. That's just built into Ruby's accessor syntax. You can use regex and case statements with any of those wins. You just put a pattern in there and have a condition that runs based on that pattern. Match is available both on the regex and string classes. Regex is also what it's called in JavaScript, and I can't tell you how much I hate that P. And really annoys me. So in my head, I just think of regex pattern. That's what it means. You can put regex in split. The interesting thing about that, so like if we were in, well, I keep going to my Quake. I want to go over here. All right. So if I've got a string, someone give me a string.
Hello world banana.
Hello world banana. All right. And I want to split this. So let's say split. If I split this on A, right, that's what I get. But if I split this on the regex A, oh wait, what am I forgetting about this? Scratch that. It's been a while since I've been in Ruby. One of the ways of using split allows you, it keeps the thing that was matched in the delimited list. I don't remember what it was. You guys can research that on your own. Scan will let you gobble up multiple matches. It's pretty great. I'm pretty sure that's one of the ones that accepts a block as well. Rindex. Anybody ever use that or hear about it? If you're reading your standard library, you should know about this. Rindex accepts regex as an argument, but begins and processes the regex from the right side of the string. That's pretty great. And then you've got enumerable grep. There's a lot of things in there. Look up grep. There's obviously sub and gsub. They do substitutions. Last I heard, oddly enough, gsub is faster than sub, even when you're only substituting one thing, which is the weird thing about that. I'm not sure why that behaves that way. Here's a quick comment about email regex. The standard library has a regex built in as a constant that you can access. You don't have to write your own or go to Stack Overflow or whatever. There's one there that's actually fairly decent. Now, one of the problems with matching email is that email addresses are famously virtually impossible to match correctly. The standards for email addresses, and I say standards because there's more than one, because there's one that deals with the email part of it. There's one that deals with the domains, right? Like whatever.com. It's an entirely different set of rules. And the email spec itself is very, 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 very forgiving. And you get some really weird, technically valid email addresses that I don't think any real email provider in the world would let you actually have, but are technically permissible in the spec. So when it comes to things like validation in your forms, on your pages, Devise's example, it's not going to catch every mistyped email address. And it may permit several examples of bad email addresses. But the front end really can't be charged with the job of making sure that someone's giving you the correct email address. That's why when you sign up for services these days, so often they say, hey, check your email to confirm your account. Because that's the only real way to be sure that this email address exists. So when it comes to writing regular expressions for validation, a lot of the time, don't go overboard on it. Let the backend do some of that, let logic do some of that, and just let some things pass through. Unless you're dealing with like a high security thing, but that's not going to be your form validations. Okay, I think that's just about all I have so far is just a quick run through of the methods. Remember, I am rusty on Ruby right now. So that's what I've got. Questions? Corrections? Yes?
So in the past 7 or so months, you've been doing so many different languages. Do you find yourself frustrated with the differences in regular expressions between them?
The only case in which I'm frustrated by the differences is in Java. And the reason is because unlike in JavaScript and Ruby and Elixir and several others, regular expressions are not a first-class data type or object type or class. So then you can't just write slash and then a pattern and in slash and expect to be able to do anything with it. You actually have to embed your regular expressions in a string. But the problem with strings in Java and in every other language is that there's a number of characters that you have to escape. And so you end up with basic regular expressions characters being something that you have to escape in the string before the regex engine ever touches it. And if, God forbid, you're trying to match on backslashes, you're going to have to escape that thing 4 times. So that and the standard way of doing regular expressions in Java, you have to build the pattern object, and you have to build the matcher object, and then you have to manually loop over the matches and deal with null and everything else in Java. Don't ask me about Java. Java frustrates me, but that's the only real frustration that I have. I mean, there's differences obviously in the different languages, the flags that are available. I've not talked about lookarounds in Ruby, which are really powerful. Actually, I'll explain briefly what those are in a second. But in JavaScript, you don't have like look behinds, which is a little frustrating sometimes, but it's all right. It is what it is. Yeah. The older implementations of regex tend to be a little more different, like you find in your Unix shell commands. Those forms of regex are a little more different, and it's been a while since I've done those in any number, so I'm much more comfortable with JavaScript and Ruby's implementations.
Is regular expressions 101 adequate for testing out things you're going to do in Ruby, or do you really need to use the Ruby?
Most of the time. I would say, well, occasionally check it in Rube Euler or in Pry or something like that. But yeah, it's the PCRE and Enigma are pretty close to one another. They both try to keep up with Perl to a certain extent, and they're pretty compatible. I don't. Yeah.
Can you cover the use case for the non-matching grouping one again?
A non-matching
group. Said something about one.
Well, yeah. So it's not storing anything in memory. Does that make sense?
So you're not actually plucking anything out of that pattern. You just want to say this matches thumbs up, thumbs down. Get some performance gain and say.
So it's what it's for is for grouping things. So this is a bad example. But if you've got a number of different atoms,
apply a quantifier after.
You just want to group them together, like an expression in JavaScript. You just got some logic you want to group together, or even in Ruby. Kid is maybe a bad example here. I could just write kid and it would behave the same way. But especially if I were going to do something like this, I can't type that kind of. All right, so if I were to say even that, whatever it is that I'm grouping together, a bunch of things, even other groups I can have in here nested, and I can have all of these groups also inside of a captured group, and that stuff will be captured along with it, but they won't be separate captures in themselves. So I've got all this stuff I want to kind of group together in some way. I can have some alternation in here. I want those characters or those numbers, and I can say all of that or this, and then at the end of it, I can say one or more. And because remember the definition of atoms right here. An atom is a character, a grouped pattern, or a position. So, and our quantifiers can augment those, any atom, really. And it doesn't make sense to the RegEx engine to match positions, really, to quantify positions for the most part. But that's an example of how you might use it. Obviously, without a bunch of gobbledygook in the middle. Does that make sense? I mentioned lookarounds. Lookarounds allow you to match things without changing where the index lies when you like finish. So for example, when I do a positive look ahead, that's one of the lookarounds. That means I'm looking ahead to make sure that the string that I want to match is followed by a comma. But I don't want, as the RegEx engine or my scan, which is looping, or my grep, as it's iterating over those matches, I don't want the next match to begin after that comma. I want it to begin at the position where the comma, or where my match ends. So the positive look ahead allows my match to end before the comma, but I'm still making sure that the comma is there. Does that make sense? The look behind is like the same thing, but in reverse. So I don't know how much you're going to use those, but that's what those do. I can make sure that the comma is there, but I don't want to change where that index is, that secret, like invisible index that the RegEx engine or whatever is using to iterate over the matches. Did starting with the quantifier and the curlies make some more intelligible sense of like the things like the asterisk and the plus symbol and the question mark? I find that does. I thought that would help. Any other questions, comments, criticisms, jokes? Cool. You guys saved me some pizza? All right.
Yes.
Cool.
Save you 3/4 of cheese pizza.
All right. Cool. I don't think I have anything else. I mean, I had some other things in case we went in other directions, but it's fine. By the way, I find that it's super difficult to find the documentation in Ruby's documentation for options, the flags. So I've had to go look in, so this is, I don't know what website this is, but they've got the Ruby Way 3rd edition up there, which is relatively recent, and they actually explain the Ruby flags. So I'll post the link to this slideshow along with any links that I've referenced and some other resources that might be useful to check things out after the fact. And so those links will be on the slideshow itself, so you can get access to those if you want. There's some good stuff out there. By the way, I'm going to sing the praises of DevDocs. Yeah, anybody use that?
What's that?
DevDocs, completely unrelated to this talk, is they actually pull either through API or through scraping documentation for 1 billion things that we use every day, and you can enable whatever you want up here, and it's just a one-stop shop for all of your documentation needs. Like, here's the Angular core library, and I can just like pull it up, and the search works pretty well, So, good stuff. I find myself switching back and forth between Indian and the Ruby docs and stuff far less often.
What was that regular expression tool that you were using?
RegEx 101. Where I have that? Oh, that's up here. Well, Now Ruby RegEx 101. This is what it looks like in real life. Lots of options. Play with it, have fun with it. RegExer is another one. You might like it better. I mean, I do like the way that it's formatted a little better, but it only implements JavaScript and PCRE, which is fine if you're testing for Ruby. You just set it to PCRE. Got your flags right there. Still pretty good. Nice cheat sheet. I like their cheat sheet better. It's not as comprehensive, but it's short, smaller, and fits on the screen. Cool. All right. Thank you guys for having me.
Thank you.